So we are simplifying radicals, and what you need to remember is simplifying radicals is simply finding a perfect square within a number so that you can perform the square root function to it. There are two ways to do it: guess and check with your perfect squares, meaning 1, 4, 9, 16, 36, I skipped 25, 49, etc., etc., etc. You would try those with whatever one you have, or you can do the prime factorization, and I'll show you both of those with number 1 and number 2. So with number 1, I have 125. I would do a guess and check in this case because I see the 25, so I would do 125 divided by 5. And that tells me that 25 times 5 is that. So I'm just rewriting it. Instead of writing 125, I'm going to rewrite it as 25 times 5. Now, because I'm under a square root, I know that the square root of 25 is 5. So I'm going to go ahead and take that out. And then I'm left with 5n underneath my square root because 5 has nothing else that could come out of it. It has no other perfect squares within it. And n is simply n by itself, so I can't take anything out of that either. For number 2, if I were to do the prime factorization, so with prime factorization, I always start with, if it's an even number, 2. If it's an odd number, I try 3. And then you go from there. But so I would do 216 divided by 2. And that gives me 108. So now again, this is a prime factorization. 2 is prime, so I know I'm done there. Then I have 54 and 2. Again, I'm done with the 2. 54, I just got to double check myself so I don't tell you something wrong. 54 is 27 and 2. And now on 27, we have 9 and 3. And 9 breaks down into 3 and 3. So with a prime factorization, you're looking for pairs. What I mean by that is, see how we have 2 3's here, we have 2 2's here, those are pairs. Now 2 times 2 we all know is 4. But again, we're underneath the square root sign. So this is actually the square root of 4, which is 2. So I just like to say if you find a match, you just use the number, and that comes outside. So 3 and 3 again is 9, square root of 9 is 3, so that comes out. And then we're left with underneath what did not get circled. So this 2 and this 3 did not get circled. So that goes here, 2, 3, again, times v, because that v can't have anything happen to it just yet. We don't have any other v's. So we get 6 radical 6v. Now in this example with 512, 512 is a big number, so I don't know if I necessarily want to do the prime factorization. With 512, I might do guess and check. So I would do maybe 512 divided by 81 first. That gives me a decimal. So I might go to a lower one and do 64. So 512 divided by 64 is 8. Okay, so that I know gives me a perfect square. So I have 64 times 8. And then I like to write, when I have an exponent, I like to write those out as k times k, because that's going to go back to what we were talking about in the prime factorization. So square root of 64 I know is 8, so that 8 can come out. Remember, k times k is k squared. If you take the square of something, the square root of a squared is what I mean. I'm sorry. I know that sounds kind of confusing. That just comes out. Let me show that to you in a different way. K squared, let's say I wrote 5 squared, if I wrote it like this. Okay? 5 squared is 25. And we know that the square root of 25 is 5. That pattern will always happen. Whenever it says a number squared or a letter squared, that can just come out because the square root is whatever that base of the exponent is. So we have 8k, square root 8, and we're not done because this 8 can be broken down. This 8 can be broken down into 4 times 2, and we all know that the square root of 4 is 2. So we're left with 16k square root 2, because that would be what was left underneath. So in number 4, again, I already know now that my numbers, my coefficients, are going to be 16 and 2. What I need to figure out is this m. So again, I like to write them out. So m to the third would be m times m times m. Here is my pair, so I get 1m to come out because of that, because together they make the perfect square. And as you can see, I have 1m left over. So I get 16m radical 2m. So now that we have that going, 216, I believe we can just go back up here. We already did the work for it, so let's not waste our time. So that's going to be 6 root 6. And now we can focus on that k to the 4th. So 6 root 6. k to the fourth is k times k times k times k. So we have 2 pairs in this case. So that would mean it would be 6k, k root 6. And again, I got this 6 root 6 from our prior work. K times k is k squared, so we would rewrite it as 6k squared root 6. Now, this worksheet has a lot of variables on it. This is just to give you practice from algebra. In geometry, we deal much more with just the numbers and not the variables, just so you know. Over in number 6, square root of 100, we know is 10. We know that 10 times 10 is 100. And again, v cubed, v times v times v. I have a pair, so 1 comes out, and I have 1 left over. Okay, 80. I would do prime factorization because it would be fast. So I would choose to do 10 and 8. And then I would do 8 is 2 and 4. 4 is 2 and, oops, that should be a 2. And 10 is 2 and 5. So I can see I have a pair of 2's here, and a pair of 2's here, and a 5 left over. So a pair of 2's gives me a 2, a pair of 2's gives me another 2, a 5 left over. And this p cubed, again, p times p times p, I have a pair, so one's going to come out, and one's going to go underneath. So we would get 4p, because 2 times 2 is 4, radical 5p. Moving on to number 8, 45. Again, that's going to be a nice quick one to do prime factorization, so I would just perform it. 9 times 5, and you might even realize right there, oh, bam, there it is, 9 times 5. So square root of 9 is 3. Square root of p squared, again, 2 p's, so that's a pair. P would come out, and then all we have left is the 5 underneath. So 147 m cubed n cubed. I would guess and check here. If I divided it by 49, I would pick 49 just because I see the 7 and I know a 9 when I multiply can make a 7 because of 27. But again, you could do prime factorization, or you can just simply guess and check until you find one. But so I did 49, and I found out that 3 times 49 is what I need. So the 49 is going to come out. So I'm going to have 7 root 3 for my coefficients, and I need to deal with the variables. Both of those are going to have 3. I'm just going to show with the m's. So I'm going to have a pair. So each one is going to have 1 letter come out and 1 letter stay under. Over here, 200 is 2 times 100. So I know there's my perfect square. So 10 is going to come out. 2 is going to go underneath the radical. M to the fourth would be 4m, so I would have 2 pairs, so I know m squared would come out, and then n would be underneath. Again, I'm going quick through the variables. On your test, your prerequisite test, there will not be variables. In geometry, we don't use the variables, we use the coefficients, so that's what I'm really concerned with. The variables are just here for review for you. 75, that's an easy one because I know 3 times 25 is 75, and 25 is my perfect square. So I have 5 root 3. This x squared is going to come out as x, and the y is going to stay underneath. So 5x root 3y. 64 is a perfect square, so 8's coming out. M cubed and n cubed, each of those are going to have 3 letters, so they would have 1 pair. So I'm going to have 1 of each letter come out, and 1 of each letter stay underneath. Okay, and the next video is going to go over Pythagorean Theorem.